Hello everyone. I don't think anyone has joined it, so let me be on mute. Hi Rohit,
Hello.
can you hear me clearly? Hello. Sorry Rohit, I think you're on mute.
I'm saying that I can hear you, but it's a kind of echoing a little bit.
Okay, some kind of echo. Okay. Okay.
Yeah, not the normal one.
Okay, give me a moment. Can you hear me now?
Yes, yeah,
Yeah. Okay.
yeah.
Uh, okay. I think we can give it a start and then others can pour in. So let me share my screen. Okay. Yeah, I hope you can see my screen.
Yes.
Okay. Okay. So, what we are going to cover when it comes to the things related to SQL. So, let me just write it down over here. So, I'll just create a notepad, or let's say I'm going to create a file called plan of action. And in that plan of action, I'm going to write what are the things that we are going to learn. Before we do this, I just wanted to confirm, Rohi, what is your confirm or what is, let's say, your comfort level with Unix?
No, I have not used Linux.
Okay, okay. So I just wanted to clarify that whatever we are going to do now, right, it's not specific to Unix. We can do anywhere. So the database that we have selected in this case, MySQL, is applicable for both Linux as well as Unix. Doesn't matter on which operating system we are, it's going to work. Okay, so that's just a clarification. Uh, Contrary to popular belief that things run better on Linux as opposed to Windows, which may really be the case for many other softwares, but it's not the case in this case. MySQL is a very good database. It works equivocally good when it comes to the Windows environment as well as when it comes to the Linux environment, right? So just for simplicity, I've selected Unix environment. There is no other reason we could have done it on a Windows environment only, right? So, but what we are going to cover is that to learn SQL, what our intention is. Let's write down the intention. The intention is clearly to learn as much SQL and ETL as possible, so that we can effectively work with data and So what I can say is, let's say, keeping in mind, we don't expect to become a DB or a database administrator, but we need to know sufficient, okay, sufficient to perform uh, multitude of tasks using SQL. And the reason why we are doing this is because many of the organizations, okay, many of the organizations have their data stored in SQL and no SQL databases. Hence, uh, we can say that by knowing the database architecture and overall how it works, along with the structured query language, okay, then we should be able to perform basic basic data engineering tasks. Okay, so that's the intention here. The intention is, not to become an expert when it comes to MySQL. We are just here to learn enough that we can do what we need to do, right? So what essentially SQL is going to cover. So by definition, as of course, as you may already be aware, SQL is structured query language, right? So this is what we are going to focus most. Okay, this is just, you can say, just another very powerful, okay, programming language, okay, to interact with RDBMS. Okay, why I'm saying this is because usually SQL is built for RDBMS, but nowadays even NoSQL databases are going to support SQL, so that is not going to be a problem. NoSQL databases is something whose applications are entirely different from what we do when it comes to the SQL databases or the RDBMS databases. That's why just to avoid any confusion, we are not going to look into NoSQL right now. At a later stage, I'll share the materials and I'll also give some overview about how they work. But majority of our data will be in a structured format if it is there in a database. If it is not there in a database, if it is a non-structured format, usually there will be NoSQL databases, and even more than NoSQL databases, there will be big data environments. Okay, so there will be Hadoop and all these things, right? So we may want to look into big data aspects a bit later, or maybe after we finish SQL, we can have a look into that. But let's start with SQL first of all. And the most important three aspects of SQL is DML, okay, DDL, and point number three, DCL. Okay, so DCL stands for data control language. Okay, data control language. Just because it says language, please don't be under this impression that we are going to learn three languages. That's not the case. It's part of the same language as the operations that we're doing. So clearly, we can write it over here, the operations that we're doing. So DML, okay, DML is the data manipulation language. Okay, DDL is used for data definition. Okay, and DCL is going to be for the control. Okay, mainly what we are going to do is we are going to do DML and DCL, because once we have done the definition, okay, point number two, I can put a note over here. Point number two above is kind of, I cannot say always, but it's kind of one-time job. Okay, so it's kind of a one-time job. It's not done always. Okay, it's not going to be done always, because the moment I define something, I'm going to stick to it, and then I'm going to play around it. I'm going to use that as much as my use cases go, right? So this is just a brief overview. I'll take a copy of this. I will be putting it into the LMS as well, so don't, that should not be a problem. Let me see if I've saved it properly. Yeah, so that's exactly what we are going to do. Intention just to learn enough so that we can do data science. The reason is that many organizations are having most of their data into SQL, and NoSQL data is still the most popular way, or still the most popular place to store the data, contrary to popular belief that people are always interested in doing big data. That's not the case. Okay, many organizations still have proprietary softwares and systems which work on proprietary way, and they have majority of their data stored into SQL based, let's say, databases. We have chosen MySQL. Oracle is the market leader when it comes to this. Okay, we could have done it using Oracle as well. The only reason why I'm not doing it is because if I download Oracle and if I download Express edition of Oracle, it gives some features, it does not give all the features. Okay, so it really doesn't matter whether I'm using MySQL or Oracle, but quickly we will be looking into Oracle as well once we are a bit done with the MySQL part of things. Yes, now we have understood that we are not supposed to look into, let's say, the operational side of things, but of course I've created a server, as I've already told you last time when we met. We already know that on AWS environment I've created my virtual machine, right? So this is that virtual machine where I've logged on. Obviously you would have guessed it. So what we need to do is that this is a blank machine. Okay, this is a very blank machine. Let me just see what kind of disk space it has. You see, I added a 8 GB disk space, right? The one that I got for free. So I have that here. And if I look at the memory, I can see that it's clearly 1 GB of RAM that I have, where 294 MB RAM is used, and almost 600 MB of RAM is there in cache. Okay, so the system has cached it, which is not an issue. When we need it, we are going to get it. Okay, now in this environment, also, or you put it this way, in an environment which is as small as this, we can also install. Okay, we can also install databases like MySQL, and they're going to work. Okay, so first of all, let's go through the installation steps. Okay, so the install steps, I'm going to write install steps, again a file I'm going to create. How to install MySQL is a very simple process. First of all, check if we have the required command line tools to download. Okay, to download the software. Okay, do I really have the command line tool to download the software? Yes or no? I have to check it first. If I don't have that, I'll be running a command to download it, so that using that command line tool I should be able to download the software package. Then I will be able to run another command to install it. So the second step will be run another command to specifically install the MySQL. Please pay attention here, MySQL community. Okay, MySQL community edition database. Okay, why do we need the community edition? Because it is completely free. It is always getting updated with new features. So to try out things, it's really the best place to go, right? So that's how it is. So we are going to we are going to effectively use the community edition for MySQL when it comes to Oracle, right? When it comes to Oracle at a later date, we are going to use Express edition of the database, although I do have the licenses to use the professional edition as well, but then that's going to be a problem for all of you, right? It's going to be a problem for all of you because you may not have the licenses from your side, right? So when we move on to the Oracle side of things, we are going to make use of the Express edition, which is the community edition for the MySQL, you can say, right? It's not really open source. Please don't get the confusion. MySQL is completely open source. Okay, MySQL is a complete open source kind of a software. Oracle is not. Oracle is always a paid software, but Express edition is something which Oracle gives so that students and universities and people who would like to try out the database can play around with it, right? Now, the second thing that we have done now is run another command to install the community edition. Once that is done, finally, the most important, so I'm going to write IMP, important step, change, okay, the root user password. Okay, this is very important. Root user is basically, okay, end of file. This is root user is actually basically the super user, the user by means of which we are going to install the software, and the user by means of which we can do almost everything when it comes to the database, right? So very important, we have to check if we have the required tool. So the required tool I need when it comes to Unix, okay, in Windows it comes by default. It is so efficient in Windows that you don't even need any tool. It is there already. It's installed within the system. You don't need to know its name as well, right? It's there already. But in Linux, you have to control everything. So I'm just going to type the command wget. I'm going to say, I'm going to see if it is throwing me an error, right? So it is throwing me an error. It is telling me the error is missing URL. It seems it is expecting some kind of a URL, which makes sense because I want to download, right? If I have to download any software, I have to go to a specific URL, right? The URL is going to give me the exe file or the execution file or the installable file. I have to go to the URL and download and install the file. So that's what it is expecting. But good to notice that, okay, good to notice that it did not throw me an error like wget command not found and all these things, which means it is installed. If it was not installed, I would have run a command like sudo yum install wget. Okay, you don't need to be an expert when it comes to Linux. A basic knowledge of Linux will do. Okay, basic knowledge of Linux will do. I will be sharing let's say materials with respect to how to have the basic knowledge of commands into Linux, and it should work. Okay, so if I do a sudo yum install wget -y, it should now tell me that it has nothing to do because package so and so so and so is already installed and is of the latest version, right? So that's the testimony. I don't need the tool. The tool is there already, right? So one thing is done. Okay, what is the next step? Next step is run another command to specifically install the MySQL Community Edition. There is something I did as a mistake. So let me just correct it. Download the software and run another command. Right, so I have to download the software as well. I've already taken up the steps. I'm just going to do a copy paste from another window, which you may not be able to see, but it is very simple. This is nothing to remember. The blog posts are there already. You can find it on the internet everywhere. I'm just downloading the MySQL 8 version here. So this is a file which I'm going to download using that wget tool, right, which I checked. So see how fast it has already downloaded. 1.74 Mbps. It has already downloaded the file. Let me see what is the size of the file. Let me just see. The size of the file is like 26 KB. It's a very small file. Okay, so I'm just going to give it executable permissions. Give me a moment. Let me just over here. Yeah, so I'm just going to clear my screen and I'm going to give it an executable permissions so that I can run it. Okay. Please don't focus much on the Unix commands that I'm doing. It's quite simple actually. There is nothing that you need to be worried about. It's a very, very simple language. I will be sharing the materials. Okay, so don't worry. Now we checked the prerequisite, it's there. We have downloaded the software, it's there. We have to fire a command to install, and the command is something like this. So it is sudo yum. Yum is a local utility tool. I'm doing a local installation using that .rpm file that I have downloaded from the internet right now. The moment I press enter, it's going to check the dependency, it's going to do all the background work, and now it is telling me that boss, I'm installing this software. Okay, from this file that you have actually given me, size of the file approximately 31 KB, and I'm going to install this. I'm going to install only one package. There is no dependency, no other package that I'm going to install. Is this okay or no? If I say yes, it's going to proceed. So let me just say yes. And the moment I say yes, it has installed the software, right? That's how simple it is. Okay, now that I've installed the RPM, this RPM, okay, actually contains the installation links, or you can say the hyperlinks or the pointers, similar to C programming, the pointers towards the community edition. So I need to run, unfortunately, another command to install the community server. And that's exactly what I'm doing. The moment I run that, it is going to do some, let's say, dependency checks and all these things. The dependencies will be clients and commons and libraries and these things. I'm just going to say yes, then it's going to download everything now. Okay, so the earlier RPM file, you can say the one that I had given it, was kind of an index file. That index file is getting referred over here from each and every website. It is downloading the data, it is downloading the softwares, and it is installing it. Okay, so I just give it the yes option there so that it continues. Let's just wait for a minute. It's going to install all the tools that I need. And then the final step will be remaining. In this case, which is really important, it is also going to be important when we are going to use the Oracle database. Okay, it's really going to be important. The moment we download, the moment we have installed the software, first thing you do, always remember this, first thing you do, you need some kind of a super user or some kind of a user. Okay, of course, when we are working in an industry, in an organization, there will be dedicated set of DBAs. Let's say Saransh, if he is working in the same team as we are, then he might be working as a database administrator. He will be setting up the environment for us. We will simply be the consumers, right? In which case we may not have to do all these things, right? But it is good to know It is good to know because now that you can install these kind of things onto a cloud environment, you can at any point in time pop up a cloud environment. Okay, you can at any point in time pop up a cloud environment and you can install the software and you can get started. Okay, later on, at a very later stage, once we are done with, let's say, machine learning, we are going to look into some containerization softwares, let's say Docker, and you will see how amazing the technology has grown till day or as of day, that we don't even have to do all these steps. You already get a container, a VM, an image, or you can say a virtual machine which already contains all the softwares that you need. Just have to download the VM, just have to configure the VM, and you will be able to install an out of the box installation for any of the databases that you want. Okay, very good, very good option when it comes to trials and POCs and learning and all these things, right? Now you can see it is completed. There is no error. Had it been there was an error, it should have thrown it over here. There is no error. It is clearly saying it is complete. So obviously MySQL command should work. Okay, now I'm writing the MySQL command, right? The first error it gives, okay, the first error it gives, it is not able to connect to my DB. Why is this the case? Let me try to understand. Why is this the case? If I look at the history of the commands that I've run, you see what I'm doing. I'm using something called sudo. I did not explain what is sudo. Sudo is a keyword in Linux which is instructing the system, sir, I have logged on using EC2 user. Please don't install this using EC2 user. Okay, my username is EC2 user. This is found using a command called who am I. If I fire the command who am I can see my username is EC2 user. Don't install MySQL using EC2 user. Install it using the super user of the server, which is the root user, right? So that everybody on the server can access it, right? So tomorrow I can create any users on this server. That user will be able to access the MySQL DB. But when I'm trying to do, I'm not able to do, right? Some kind of a permissions are missing, which we are going to fix at a later stage. Right now, what we can do, we can become a sudo or we can become a root user using the sudo keyword and we can run the command. So what I'm going to do, I'm going to say sudo MySQL. In place of MySQL, I'm going to say sudo MySQL. In that case also, it is showing me an error. Why is this? Because MySQL by default, okay, unless and until you have installed a proper industrial version, this is a community edition we have installed. If it is a proper industrial version, it will not have this kind of problem because there will be a lot of properties like password embedding and encryption and all these features. Because this is a community edition, it requires a username and password. So the moment you give the username as -u root, okay, it is still saying there is a problem, right? Then I am giving some kind of a password. Do I know the password? I don't know what is the password, right? I can try anything I want over here, and if I enter, it is still going to tell me that it is not able to connect into the MySQL DB. Okay, you can ignore the file name it is telling you about now. Socket file, this file plays a very negligible kind of role. It's just a local file which helps you to connect to a MySQL database. That's all. Okay, but I'm still not able to connect. I don't understand. The basic reason is, again, I'll go back to my install file and there is something that I need to run over here. Is that important thing that I need to do over here. This is really important. Even before I change the root user password, start the MySQL database service. Okay, and finally change the root user password. Okay, so what I mean by that is I have to start the MySQL database service because I've installed it. Even in Windows, I have to go to services.msc and I have to start it. In this case also, I have to start it. Okay, so before I start it, of course, I should be looking into the status. So to do that, I'm going to fire a command sudo. Again, I want to act as a root and fire a command sudo. The command name is service. I want to see if MySQL D is the process name of the database, MySQL database. So the short form is MySQL D. What is the status of that service? Is that running? Is that stopped, or what it is? If I run this, I can clearly see it is inactive. The status is dead. It is not running. That is the reason why I was not able to connect. It has to start. It has to run first. Let me do a restart. Okay, if I do a restart, it should work now. I'm going to do a restart. Then I'm going to check what is the status of the service. It should be in a started mode. Let me just see what is the status of the service. Now you see it is active and it is running, right? It is actually running on the server. Now I should be able to log into the database. Let's see. Now I have a different problem. When I am doing a sudo MySQL, even if I don't do a sudo MySQL, it is again saying MySQL ec2-user at the rate localhost using password no access denied. This means I have to set the password. So that's the last step I need to do. Unless and until you set the password, you wouldn't be able to access. No user will be able to access it. So you have to set the password first. Okay, you have to set the password. You have to set the password of the super user or any other user you want to use, okay, to log in inside the database, right? Because this is the first time, okay, because this is the first time we have started MySQL, there is a file, there is a log file which contains all the logging information of what we have done to start the database. Okay, we are simply going to search for a particular keyword in that file, which is going to give us the initial password. Initial password will be available from the log file called mysqld.log, and I can clearly see I don't have the permission, obviously, because I've done the installation using root user. I am firing the command using ec2 user. How is it going to run? So I'm going to do a sudo, and it tells me this is the temporary password. Okay, this password will not be the same for you. If you are installing this, you would have got a different password, right? But look at the way the password is created. It is alphanumeric. Small caps are there, numbers are there, special characters are there. So it's an indication of how good a password should be for you. When you are going to set the password, this is how it should be, right? Now I'm going to run a utility called MySQL Secure Installation. MySQL Secure Installation, and I'm going to run the utility. It is going to take 1 minute of its time. It's going to ask me a couple of questions, and basis those questions, I'm going to change the root password. Okay, so let me copy this password. Okay, let me copy this password, enter the password for root. I enter it over here. Existing password for the user account root has expired. Please set a new password. I'm doing that now. Okay, re-enter the new password. I'm doing it now. Estimated strength like 100. I don't understand what it is saying. 100, I don't care how good, how bad it is, right? But I'm going to say change the password for root. It is asking yes, no. I'm going to say yes. Right, again it is asking me for new password, so let me just enter the new password. I think I should have okay, I think it is done. Do you wish to continue with the password provided? The answer is yes, I would like to continue. Now it is asking, there are a lot of anonymous users which are there in the DB. This can be a problem. Do you want to remove the anonymous users? The answer is yes. I'm going to say yes. Normally, root should only be allowed to connect from localhost. This ensures someone or anyone cannot guess, okay, the root password. Do you want to disallow remote login? I'm going to say yes. I'm just following the default options. Okay. Again, it is asking for removal of some test DB. I'm going to say yes. Reload privilege tables. Now I'm going to say yes. All done. Okay. It is saying all done. Now I should be able to log in. How? MySQL -u root -p and the password. Okay. The password that I have given. So let me just do this, and I will enter the password that I've set. I'm inside the prompt. Installation is done, my friends. Installation is done. I am able to change the root password. I was able to log it into the system. Okay. I can also create the EC2 user as a user inside the database, give it a password, and by not using root, I can also start using EC2 user. Right? Clear cut. Okay. Give me 1 minute, friends. Give me 1 minute. In the meanwhile, if you have any questions. Any questions, friends? I hope you can hear me, right? Okay, there is a question. Sorry, I missed the chat window. Sorry. So in short, so MySQL is pre-installed. We need to set up user credentials, continue using it. No, Sarangs, it is not pre-installed. If you look at the commands, let me just exit from here and let me just show you the commands. Exit is not working. Why? Okay, the command was why. If you look at, sorry, history, and I'm going to say history grep yum. So what we have done is, first of all, we installed the wget tool. Wget tool is used to download the software, any software, right? Then I'm going to go to, I'm doing a local install of this RPM file. Okay, this RPM file is the index of from where MySQL Community Edition DB is available. That index has to be installed first. So I installed the index first, then I installed the community server. So I have actually run commands to install the DB. There was nothing on the virtual machine, right? You can get virtual machines on AWS pre-installed with MySQL. That may even cost us. I didn't want to take a risk. I went with a plain and simple blank host, only 1 GB RAM, 1 core CPU, free tier, and simply I have installed the MySQL Community Edition with these commands. Right? Once that
Okay,
was done, yeah. Once that was done, then I went ahead, changed the root password.
Okay. I just thought that with the EC2 instance you have created, it is already loaded.
No,
The
no.
files are
With
already
mine
loaded.
one, it was not there. No.
Okay.
You can have that, by the way. That is not an issue. You can have that. Okay, but that was not the case in our case. Okay. Now let's again go back to our prompt. Before we really look into the details of the database, let's just quickly, okay, let's just quickly look into some of the architecture of the DB. In any MySQL DB, okay, this is, consider this to be our DB. This is our MySQL DB. Okay, in our MySQL DB, the first thing that we are going to have inside the database, okay, is a database. Okay, this is a very confusing kind of a concept. So please ask me questions if you are not clear on what I'm saying. Inside the database, okay, just a moment, one more question is there. Can't we install MySQL from AWS Web Console? No, Rohi, we cannot do that because AWS Web Console is for the administration of AWS related things. Example given, you can make changes to the virtual machine. But if you want to install software or change things inside the virtual machine, you have to log in. You have to log into the virtual machine, then you can change. Right? There is one more option. When you are creating a virtual machine, you can give a startup script. But you have to be very careful with the startup script. It should not have any errors, or otherwise your virtual machine might become unusable. That's why I did not use a startup script. Using a startup script, what you can do in any cloud platform is that the moment you are creating a VM, you are giving a set of, let's say, commands similar to the yum command that I just showed you, and it is going to by default run the commands. So you don't have to log into the server and run all the commands. It's there for you. Okay, but we have not done that. Why? Because we don't want to take a risk. We don't want to take a risk with the fact that if something goes wrong, then I may have to uninstall or destroy all the servers, and then I have to do the reinstallation. Right? So why to waste time? We logged on and we did the change. Now you want to do administrative things like I want to change the IP address from where I'm logging in. Right? I want to change, let's say, the public IP address of the VM. That all are the things from the AWS console. So AWS console is for management of AWS resources. Within the resources, you have to log in, you have to make the change. Right? Now, the first concept is a very, very confusing concept. First concept, MySQL is a database software. Okay, you have to consider this as a software, just another software. This is a concept on which MySQL is built, because the moment you log into MySQL, and we are going to see commands here as well, the moment we log into MySQL, we can see there are some pre-created databases which are already there inside MySQL. Databases are, now this is really going to confuse you, logical as well as physical entities. Why logical as well as physical entities is because logically I am giving them a segregation. I am giving them a name. Okay, I can give them different names, different locations, but physically they are nothing but disk files. Okay, they are basically files on the disk. That's all. But they are logical bifurcations. Then why am I creating different DBs? Okay, this is to have a lot of features inside the database. Example given, user access management. If there is a user U1 who should have access to database D1, and there is a user U2 who should only have access to database D2, this is one of the ways in which I can control it. Okay, this is the one of the ways I can control it. I will not give U1 access to D2. So I will create separate DBs and I will give access to separate user to the DBs. Right? That's the first point. That's the first point. You have a DB. Okay. The second point is, inside a DB, you are going to have a logical schema bifurcation. So that bifurcation is called a schema. So let's say I have a DB D1 or DB1 and DB2. Okay, DB2, okay, DB3, and so on. Okay, I have 4 DBs, let's say 4. Inside one, I can have, let's say, 2 schemas, schema 1, okay, and schema 2. Okay, usually this was the original concept of RDBMS. Okay, this was the original concept of RDBMS, where inside a DB you can have schemas. How MySQL simplifies it, it says, forget schemas. Okay, you have already created a DB. Let this be both your logical and physical bifurcation. Right? That is the reason why you do not need any schema. You can consider this DB itself as a schema. Okay. Now, what is actually schema is basically, if you remember, when we were looking into data warehousing concepts, we looked into things like ER diagram, like entity relationship diagram, where we created a star schema. There was a fact table and there were 4 dimension tables, right? There were joins only to the fact table, right? Dimension tables were not connected to each other. The dimensions were joined with the fact table. So this is a schema. This is a ER diagram, and the practical or the technical implementation of this ER diagram is otherwise known as a schema. It is just a structure in which you are going to put all your database objects like tables and views and indexes and all these things, right? That's all. Now, inside each and every DB, obviously the most common structure that we are going to have, one is a table and one is a view. You can have many more things like procedures and packages and executable code, Java code, and all these things. The most common things, the most common thing we are going to use inside the database, as simple as it sounds. If we have a database, I should have a table. If I have an Excel sheet, I should have a worksheet, right? I should have different tabs inside an Excel sheet to work on. In each tab, I'm going to keep in each kind of data. The same way, inside a DB or inside a schema, let's say schema number 4, I'm going to create tables. One table I'm going to create with respect to maybe the employees in my organization. The other table I'm going to create with respect to their salary. The other table I'm going to create with respect to something else. Right? These are logical bifurcations. Okay, these are simply logical bifurcations. That's all. Right? So that's exactly what we are going to see over here. We're logged into MySQL. I want to know how many DBs or schemas are pre-created. I can also create my own. I'm going to look into this thing if I can. Okay. And then I'm going to look into the tables and views which are there inside the databases or the schemas, and I'm going to start using them. Even better, I will create my own. Right? I will create a new database. I'll create a new database called Students DB. Okay, we are going to create a new DB called Students DB, new schema, where I'm going to create 3 tables. One will be a student table, where I'm going to have the name, the student ID, login ID, age, GPA, and so on. The other table will be like enrolled table, which student is enrolled in which course, right, and what kind of grade he or she is getting. And the third table might be, let's say, a table containing details of the courses, which is going to have the course ID and the name of the course, right? So let's jump over to the practicals, clear all drawings. Okay, let's see what kind of databases we have in MySQL. Now come the MySQL commands, friends. Okay, Linux is done. We don't need any more Linux right now. We may need it later on when we are going to import and export CSV files. But we are going to work only on the commands here on this screen, which is specific to MySQL. Okay, everything is there in the MySQL documentation. Just look at this version. Okay, server version 8.0.21, right? MySQL community server. Just take this and go to Google. You will find the documentation. You will find all the commands. Okay, but I would just like to see what all are the databases which is there. The simple command show databases. By default, it has created 4 databases: information schema, MySQL, performance schema, sys. Okay, what are these for? Information schema gives the metadata of the DB, overall metadata, not in depth, overall metadata. How many tables will be there, how many structures will be there, and all these things, where installations are done and so on. MySQL, system database, or I can say, I will not say system, that name will be wrong because we have another system. So I'm going to say this is the installation database. It's going to have details related to the installation. The performance schema, it is going to have details related to the SQL queries that I'm firing, or the performance of those queries, or the cardinality of those tables and all these things, right? Just like when we are going to see firing queries in the background, MySQL, or for that matter, any database creates an execution plan. It creates a plan in which it is going to execute the query on the database, looking at the property, looking at the metadata of the tables. Then finally, the most important, sys. This is system. Okay. Inside system, you have everything. You have everything. How many users are there? What is their password in encoded form? How many tables have they created? When did they log in last? How many queries are they firing? Are those queries good or bad? All these things. These kind of information. So you can say these are, let's say, subsets. Okay. So I can say information schema is actually a subset of sys. MySQL is kind of a subset of sys. Okay. And this performance schema is also a subset of sys. Okay, there are some more information, additional information, which is there in these 3 schemas, but main information is inside the sys schema. But we have said that our plan of action is we are going to create a new DB. Create database students. Okay, or maybe even better, I'm going to call it classroom. Okay, create database classroom. Let me fire show databases. The command should be telling me that now I have a new DB called classroom. Only drawback of this command, you don't know if you have created the database or the system has created the database from this output. Right? From this output, you cannot say who has created which database. Okay, you cannot say classroom was created by whom. Right? The name of the author is not written over there. But we are going to find that detail later. As of now, we want to use the classroom DB or the schema to go inside it, and then we are going to create all the tables and views and all these things. Hence, I'm going to use a command called use classroom. Right? It says database changed. Now I am inside classroom. I can still fire cases, I can still fire commands like show databases. But now, whatever objects or whatever activities I'm going to do, right, it is going to be inside the classroom schema. Right? As we have planned, we will create 3 tables. Right? We will create 3 tables. So let's write it down first. VIR tables. How many tables do we need? How many tables do we need? How many tables do you need? In this case, first of all, I think I'm going to have a students table. Okay, I'm going to have a students table with some columns like student ID, name, the login ID, age, and GPA. Okay, so that's the first table I'm going to create. I'm going to create them with lowercase. Let me just change this. The second table I'm going to create enrolled. It's going to have the student ID, the course ID, okay, and the grade of the students. The third table is going to be the courses. The course which is there in my classroom. So it's going to have a course ID, okay, and the name of the course. End of file. Intentionally, as you see, I'm doing something intentionally, which will come into effect at a later stage when we are going to write queries. Intentionally in students table, and in the course table I have selected common named columns. So there are columns named name which is the same in both the tables. I could have said in students table it is student underscore name. In course I could have said course underscore name. I did not say that. Okay, there is a reason behind it. When we fire queries, we'll come to know. Okay, saved. Let me just see if our strategy is clear. 3 tables I need: students, enrolled, course. Okay, what I'm going to do is that I'm going to again log into my prompt. Again, I'm going to log into my prompt and I'm going to pass the password. Done. I'm going to use classroom, right? And I'm going to create my first table. Because I'm creating a table, I have to tell the database how the table's structure will be. In other words, what is going to be the definition of the table. That's why the type of command that I'm going to use now is also called DDL, data definition language. Okay, but hold on. I typed a command here, but it did not give any error. Okay, DDL is not a command in MySQL, right? But I typed it, but it did not give me any error. Why is this the case? It's because I've used the syntax double hyphens. Okay, so double hyphens in MySQL is a comment. Okay, you write anything after the double hyphen, it's not going to give an error. It's treated as a comment. Just like in Python, it is hash. In SQL, in MySQL, it is double hash. Okay, double hyphen will also be used in Oracle DB. Okay, so I'm going to say create the table students using data definition language. Right, I'm going to create the table now. Create table students. This is a command to create the table. If I fire this command, it's going to give me an error. Right, the error it is giving is a table must have at least one column, or otherwise it's not a table. So how do I define that? I've already said that my table, where did my file go? Where is my file? Here. So students table should have these many columns. I have already said that. Okay, so let me copy this and let me just create a table with these many columns into bracket. Right, it says check the manual for the right syntax. Why is it saying so? Because for none of the columns I have declared what type of data it is going to store. I have to provide that. So to do that, what I'm going to say, SID is going to be an integer. Okay, name is going to be variable in character length. Right, login is again going to be a variable character. Age is going to be an integer. GPA is going to be a float. Right, again I get some errors, which means even if I am providing the data type, it is not accepting it. Why is that so? Only reason here is there are some data types which requires the size. For the rest, it is optional. Example, integer, I don't have to define how long the integer will be. But if I am saying a field like name or login is going to be variable character, or it can have variable characters within them, it can have numbers, letters, or the special characters. I have to tell the database that was fixed this much size for me. If I'm not saying that, how does it know how much size to give? How much space you need to store the data? So that was the problem. Let me fix it. So for login, I'll say my login ID will not be more than 20 characters. And my name, fine, I'll give it, it's a 50 characters. There will be people obviously like me. If you look at my name is also very lengthy, right? So there can be people with longer names. I'm going to give it like this. Now it says query OK. Right? Query OK, 0 rows affected. Why 0 rows? Because this is a DDL. It did not change anything. This is not a DML that you are modifying something. It is a DDL. You are simply creating a definition. How to verify whether your definition is correct? Show tables. Just like show databases, next command in the row, show tables. Now again the same problem. Who created the table? Where are the columns? I don't know. For that, I'm going to say describe students. Now it gives me a full picture of what I have done when I've created this table. I did not enter values of fields like null, whether it's a key or not, what will be the default value, extra notes and all these things. These are all optional things. Okay, these things, the ones that you see over here, let me just quickly tell you, these are optional things, but they are important in some cases. Example given, this field null, if you set it to no, it means it is a mandatory field. Example given, if I said student ID null equal to no, then for each and every record in the table students, there must be a student ID. So ideally, I should have given this a no. Okay, because we are playing around, I'm not really bothered about each and every constraint and all these things right now. But ideal condition, I should have given it. What is key? This is something that you can read and find out. The most prominent keys that we have already seen when we were looking at the ETL diagram slide, we have looked into primary key and foreign key. So primary key is the unique or combination of unique columns within a table, in this case students, and foreign key is going to be, let's say, the other table's primary key. So in this case, because this description is relevant to only this table, so there is no reason to believe in foreign key right now. We don't have to cater about foreign key, because foreign key will essentially be a primary key in some other table. So let's focus on the primary key of our table, which is students. I have not given any column as a primary key. Ideally, I should have given the student ID or a combination of student ID and name as the primary key, but I have not done that. Right? The third column is default. Is any column going to have any default value or no? Let's say I want to create a table like students where the default GPA of all the students will be set to 0 by default. I don't want to insert any value. By default, the data is set to 0. What do I mean by that? When I'm going to load data in this table, if I have already set a default value for this column GPA, then I don't need to write explicit insert commands. Right? And this extra field is for comments. Okay. Unfortunately, we don't have more time right now. Let's make a close now. Okay. We have just created one schema called classroom, and we have created our first table. We will continue from here. We have 2 more tables to create. Okay. Thank you so much, friends. Good night. Thank
Thank
you so
you.
much. Thank
Good
you.
night.
Thank you.